we will actually see. I cannot tell. Let's see how this goes. All right, so welcome to the second part. Yay, we're all excited, right? Yeah, woo, yay. Yay, Dad, right? Yeah.
This was 2014?
2114.
2114, thank you.
Yeah, it's 2114. Physics 2114. There are no assignments currently available because I haven't assigned diddly squat yet. Yay. So big part right now is to make sure that you can get into WebAssign and attach your book. I will have assignments set up by Wednesday. Okay, so I will get that going by Wednesday. Last week was just a tad bit crazy. And for those of you who had me over the summer knows that the summer was just a tad bit crazy. So we've got a lot of things that we're pulling in together and trying to get stuff to going. But the course key is on Blackboard. So if you log into Blackboard, what you will find on Blackboard right now is the syllabus. Nothing much has changed, same type of grading system, nothing much has changed at all. Doing your homework is going to give you success in the class, right? Doing the homework is going to give you the most success in the class all the way around. Second part of this is you do have the course key. It's also underneath the syllabus. Big things that you guys need to know. For you guys over in Enid, it's a little trickier, okay? Over in Enid, it's going to be a tad trickier because you currently have a lab scheduled for 7:30 on Thursday morning. I will tell you that there will not be a lab at 7:30 on Thursday morning over in Enid. We are going to figure out a time when I get over there on Friday and figure out when best to do it because it's just you and Ed, and I'm hoping we can do it right after class on Fridays because it won't take long to do the data, collect the data, and we write lab reports after that. So that's what I'm hoping for you guys over in Enid. The rest of you over here are on Wednesday afternoons with Mr. Grimm. Now, here's a question because I don't know because it's been over the summer. Did you guys get a lab manual at the bookstore? Okay, there is no lab manual. Okay.
Well, I haven't gone to the bookstore.
Oh, you haven't gone to the bookstore. But I know there's other people who have gone to the bookstore. And the bookstore it told you, hang on, worry about Cengage here in just a second. So we're going to talk about Cengage real quick. But as far as a lab manual, I couldn't remember if there's a Physics 2 lab manual or not. And that's why I was asking the question. If not, then I'll do the exact same thing I did last semester, is I will post them for everybody, and everybody gets them at the same time. There shouldn't be, Mr. Grimm will have seen all the labs, but I'm hoping to get our lab manual straightened out. Cross my fingers, this semester's already starting out crazy, so we're giving you a heads up on that. So that's where we are there. Okay, everybody get your calendars out, because it's going to be fun. All right? We will meet today, Wednesday, and Friday. This week we'll go nice, peachy dandy, no problems. Next week, we will not meet on Monday. We will not meet on Wednesday. We will meet on Friday. Okay? And I believe for you guys over here, it's the same facilitator that we had before. So it'll be the same person that you guys are used to. I will be in San Diego next Monday and next Wednesday. Which means also the following week, which is Labor Day, we will not meet on Monday because that Labor Day is a school holiday. So we will, but by the middle of the first week of September, we will have gotten through simple harmonic motion and sound so that we will still be on track to have a test towards like that 5th, or is the 6th of Friday? Who's got a calendar? Come on.
Yes.
6th is a Friday. So plan on a test Friday, September the 6th on waves and sound. What we're going to do lab-wise this week is simple harmonic motion. And then next week, you guys will be measuring the speed of sound. But labs are gonna be just fine, because I should get back around midnight on Wednesday from the San Diego meeting. So that's one of the big things that's there. If you have a computer that can download SolidWorks, I strongly recommend that you go ahead and do that. I will get the SolidWorks stuff posted. We've had experience now taking the exam so that you can get certified on the exam. It is not trivial if you want to get certified on the exam for SolidWorks for going on to OSU or to the Bell program. If you are interested in the Bell program, we have 4 people that are up there now. Peyton's up there. All right, there's the rest of them. Everybody's here. Woohoo! We have the rest of them where our Peyton, Kristen, Riley, and Brandon Hillhouse are all up at the Bell program. And from what I've seen coming back out of the first 3 weeks, they are stoked. They are totally stoked.
Kristen is loving it.
Kristen's having a blast. I mean, they are totally stoked. So if you are thinking the Bell program might be for you, or you want to know more about the Bell program, come holler at me, because we're going to try and get coordinated so that Cody comes down and talks to us again. And if you are interested, they probably will do a Bell experience over the Christmas break like they did last year, or maybe a Bell experience in May. It seems to be a really, really good opportunity, so that's something that you guys might consider. Also, don't forget, we are still soliciting for the Berlin study abroad trip. People are getting real excited about that as well. If you're in statics or an architecture major, that's definitely one to look at for spring break. And I have all kinds of nice glossy flyers now. Also, to kind of talk to Wes Watkins, who's our study abroad coordinator. He talked about a couple of ways to fund the study abroad experience, and he says that people have done quite well with it. If you are concerned that you don't want to sign up because you're afraid that you aren't going to be able to collect all the monies to do so, he said that really all you're out is that $95 deposit. If you have to back out at the last minute, that's really what you're out, that and the insurance, and we do require that people pay for the insurance. But the other thing is once you do that, you can set up a page through EF Study Tours that does a GoFundMe. And he says that a lot of the students down at OSU get their funding by sending that link out to their aunts and uncles, and at $5 a pop, they actually collect quite a bit of the funds for it, for birthday money, that kind of stuff. So he says that option works really well. We would like to try and do, I only got one sign up over the weekend for the club things, for the engineering/science club. That is an opportunity for us if we wanted to try and do a fundraiser. So that's something else is out there. But there are opportunities for scholarships. There are that part. And we did talk to Wes quite a bit on Friday. Now, there are 2 classes that you can get credits for that they will carry the I designation for Oklahoma State, which is really important because apparently that I designation is a pain in the tushy to get. Mr. Wes Watkins will do the humanities part, and I will do the engineering part. So that part's already been laid out, and those courses will be available for the spring as well. So just be aware of that piece. So it's kind of just thinking ahead. Okay, so let's talk Cengage. For all of you, you have a Cengage book, which is the physics book, but you got Cengage Unlimited last spring for our book. And as I understand it, because I was on the phone with Cengage quite extensively, that because we were Cengage Unlimited and we got Cengage Unlimited with our book, it will carry over for engineering physics too. We're not 100% sure if it carries over for calc, because calc did split that fee up. Okay, calc split the fee up. So I don't know for 100% for sure if calc will carry on as a continuation course or if you're logged in right now under a guest registration. what hopefully Ms. Hook said to you guys and Ms. Cooper said to you guys, if depending on which calc you're in, said that wait until you heard from me to talk to you all about all the ins and outs of Cengage before you did anything as far as a fee. So your calc books, your differential equation book, the engineering physics book, also on campus, it includes computer science is one of the books that's a Cengage book. We have several different books that are Cengage books. Unfortunately, the thermodynamics book is not a Cengage book, and the statics and dynamics book aren't the Cengage books. So just be aware that in the engineering program, those are the ones that aren't, and chemistry is not a Cengage book right now. So those are the ones that aren't. But you can get or upgrade your current subscription to a Cengage Unlimited. Just in your calc book and your physics book, it does pay to do your Cengage Unlimited. Totally pays for it. I mean, it's the best deal around. For those that are incoming freshmen, so if you've got a buddy that's an incoming freshman that's going to be an intro to engineering on Tuesday, tomorrow morning, we're going to talk about it for them. It's worth it to them to buy the 2-year subscription because their intro to engineering book, their physics book, all their math books, computer science book, a couple other books are all Cengage, and that 2-year Cengage Unlimited covers it. The bookstore currently does not have cards for the 2-year, but they will by the end of the week. So they can go in on a guest registration and then at the end of the week get their 2-year subscription cards. The bookstore will also be selling the unlimited going forward. The other tidbit is, from what I understand, is you can carry it from school to school. So if you wanted to purchase the 2-year knowing that you're going to be at Oklahoma State and Oklahoma State's going to do Cengage books as well, then that's one thing that you may want to look into. Now, for those of you who got Cengage Unlimited over the summer, because some of you did via a math class, some of you did via my class, if you got Cengage Unlimited over the summer, it was a one-term, 4-month access. But my understanding is as follows, that as long as you attach the book to your account right now, before that 4-month expires, you have that book and that course until the end date of the course. So calc starts now, goes through December. If you add it to your Cengage Unlimited right now, our understanding is, based on what our bookseller told me on Thursday, is that you've got access to your calc book until the end of the semester. What happens is, coming the end of that 4-month time period, which occurs sometime in October, if I remember right, when we were calculating the dates, it's like early October, because it was late July, somewhere right in there, that if you were to have like a late 8 class that's a Cengage book, you may not be able to add it because it's after your Cengage Unlimited expiration is. So, to me, looking at the pricing of everything, Cengage Unlimited is the way to go. It's just a matter of whether you do it the 4-month term, the year term, or the 2-year term. So that's one of the things. So look at it. You've got until August the 30th to opt out of being direct billed for some of your books. And the way you go to find out what book you're being direct billed for is you should get in your student email, you should get an email that has a link that has, here are all the books that you're being billed for through your bursar account. Now, for those of you on scholarship, those of you who are getting something paid for via something along the way, yes, there is a markup through the bookstore for Cengage Unlimited, but your scholarship pays for it and goes direct through the bursar account, and so you guys don't have to worry about it. If you aren't on scholarship, you may want to go ahead and not purchase it through the bookstore, but go to the Cengage site and pay for it direct. And my understanding is, even though we didn't see it in the summer, because we tried, that the 1-year and 2-year option subscriptions are there. And if not, and you can also go ahead and upgrade your current subscription. So We will be hearing more from Cengage come September as we start doing books for spring. But for you guys, you need to look at, one, what is your current Cengage Unlimited subscription? And is it going to cover everything that you need? And then you can possibly upgrade from your Cengage, and then look at that by October or August the 30th to decide whether or not you want to opt out. Okay? So that's one of the things that you just got to kind of look at from a Cengage point of view. So questions, because we can work through those pieces as we go. Yeah. Probably need to call them and find out about their books. I don't know which books they're using on certain things. Yeah.
So I was looking at Cengage and it looks like it's the same exact book for Engineering Physics 1. Is that true or no?
Yeah, it's the same book. We're just doing the second half. Yeah, we're doing the second half. Sort of. Second half. Because the way she's ordered the book, it's a little different. So, and I'm going to add in ours, I'm going to add the old Searway book as well, so that you have both books, and give you the link to the OpenStack book as well. Yeah.
So ours, did we get a 12-month subscription last year?
My understanding is you got at least for engineering physics, it's a continuation course. And and this is one of the things that we asked Susan to help us with, was how to verify what your subscription actually is, because it's not clear. We tried to look at it last week on a couple folks's, trying to figure it out, but I don't know if we got you a full year or a 4-month term, but because my course is a continuation course, it certainly is good for engineering physics too.
Well, at the bookstore, they said that supposedly if I had Cengage Unlimited, which I think is what we had,
Right.
that I could opt out of any Cengage-related class, and it should.
And it should, yeah, the question what will come up is when you add, if it's going to flag anything, is when you add like Calc or one of the other Cengage books.
Okay.
Yeah. And that should give you a flag, but if it's a 12-month Cengage Unlimited, then we are peachy dandy hunky dory.
So how would we go about adding the other classes?
You go to when you go on your Cengage Unlimited, there's going to be a place, and I'll have a button, add another course, and you add by the class key. Yeah.
So register another course or product?
That's it.
So where do we get the class keys then?
This is my class key, but math should post their class keys.
Well, like my calc is already on here.
Your calc is, yeah, because we did yours last week.
Oh. So then, but do I need to opt out?
I don't think so.
Or,
Oh, no, yeah, you need to opt out of the calc bill.
okay.
Yeah.
So the Cengage Unlimited that we did during the summer, that was a 4-month, right?
That's a 4-monther.
If we get the calculus to go now, we can.
It should carry over until the end of calc.
Okay. There wasn't a key to do. I just added the book manually. Can you do that?
You can add the book manually. You can add any book, but like WebAssign, you got to have the class key.
Okay, thank you.
Now, I know Ms. Hook and Ms. Cooper. Now, Ms. Cooper may or may not, if you're in Ms. Cooper's class, who's in Ms. Cooper's class? Okay, if you're in Ms. Cooper's class, we're doing exactly what we did last semester with Ms. Hook's class, because Ms. Cooper did not know that she needed to have the class key, and we're having to do the backdoor in. Okay? So right now, you're in the same bind as we were last spring with her class, but Bobby's working on it so that it should roll over and you should be able to see WebAssign and everything. And she's going to do a mass edit, so it's probably going to be seamless for her stuff. If you're in Ms. Hook's class, Ms. Hooks should give you a class key. If you're in whoever's teaching differential equations, the differential equations should also give you a class key. Because we talked about it last Thursday, and they were creating their classes with a class key, but Ms. Cooper had already created her class without a class key, and we were having to fix that. Okay, yeah.
How would we upgrade it from the 4 months to the 1 year?
There's a button inside Cengage Unlimited that allows you to do that.
Or there on the internet?
Now, that's one of the things that we haven't figured out is if you can go buy a card and how it stacks on top, because we didn't get into that with Susan because we had too many other issues that we were trying to solve last Thursday. Okay. All righty. We good?
On my website,
I got it.
You got it? Okay. There won't be any assignments on mine.
I know, but yours isn't even showing up on mine. Like it
Yeah.
isn't.
Did you register the product already?
Yeah, if you're coming in from WebAssign and Calculus and you're in Ms. Cooper's class, we're having the same problem that we had last semester.
So do we just wait until the free trial's up, or do we go ahead and buy?
Well, if you know what you're needing, then go to the bookstore and pick up the Cengage Unlimited card. But I can also tell you that if you want to go ahead and do the 2-year, they won't have the 2-year. Right now, I think what they have for us are 4-monthers.
Okay.
Because this was the second half of my course. And so what she has right now, I think, are 4-monthers. She may have some full years because my Gen Physics course is a full year. So she may have some full years. But come like Friday or early next week, she should have a 2-year one at the bookstore. So and again, if you're on scholarship, it's better to go through the bookstore than if you're not on scholarship and you're paying out of your pocket, it's better to go ahead and buy it off of the website. The only downside to Cengage Unlimited that I see so far is you don't get a physical book. And that is a pain in the butt in some cases. Now, I do know that Computer Concepts actually is requiring a loose leaf book as well, and it's part of how they've worked it out with Cengage. So particularly for the online class, because people don't have 2 screens.
Yeah, that's what I'm in.
Yeah.
So like, I got my physical book, which was included.
Uh-huh.
So then
They still say opt out.
still opt out.
Mhm.
Okay.
Because it's
like,
a deal,
there's
it's a
nothing
deal
on
that
there.
we've made with Cengage for the online class.
Okay, so I need to opt out of both these books.
Yeah, you need to opt out. Your specific situation is opt out of the ones that are direct billing you.
Okay.
Yeah.
So I'm in the computer concepts class as well,
Mhm.
and will they give us a class key that we're supposed to use before we opt
You probably ought to ask them for the class key.
out? All right, and then same with the national government?
Yeah, same with government. Yeah. There should be a class key, or in their case, because they don't necessarily do online homework, you may be just able to add the book
And not have to worry about that?
and not have to worry about it. But double check with them because the idea behind Cengage Unlimited, if it's any Cengage book, you're supposed to be able to have access to it. The question then becomes online homework.
Okay, so then, like, I'm still having trouble, just go to the IT department then?
Or flag it for me so we can talk to Cengage, because I was on the phone with Susan for about 45 minutes last Thursday trying to figure it out.
Okay.
And got the math people all confused. I didn't even go to computer science or American history or those guys. I didn't even go there. Because for you guys, because between math and physics, those are the expensive books anyway. And when you look at going to buy a physics book outright, that 1-year unlimited subscription, dirt cheap compared to buying the physics book outright. So, I mean, it's a no-brainer for you guys. So that's what you need to tell anybody in Intro to Engineering tomorrow. That's the newbies, the new coming freshmen who are in fast track math and the plane trigonometry and all of that. That 2-year deal is the way to go, because if they're staying with us for 2 years, I'm staying with a Cengage book. So that's where we're at. Okay. Other questions? Now, did you get the message over there that we're going to try and do, because since you came in late, that we're going to try and do lab after class on Friday instead of 7:30 on Thursday morning? Figured you guys like that.
Yeah.
I'm your lab instructor. We'll do it right after class. get it done.
Are we having a lab on Wednesday?
Yes, you're having lab on Wednesday.
Just make sure.
Yeah, you're having lab on Wednesday. So again, Monday and Wednesday of next week, I will put an announcement out. I will not be here physically. Okay? That does not mean that there aren't things for you guys to do. As you all well know, I never don't leave something that you guys aren't busy. You guys are always busy, right? Engineering students, always busy. Okay, so your first assignment is, one of the things is going to be that you have to find, and I will post it in Blackboard, is you have to find an example of simple harmonic motion. You need to get a video snippet of said example of simple harmonic motion. And you will need to write out the wave equation for simple harmonic motion. It's going to be worth 50 points. And creativity is definitely get you bennies. Okay? Get you bennies. Because I don't want to see the two common examples of simple harmonic motion. Okay? Common example number one, the simple pendulum. Okay? Common example number one, the simple pendulum. It is a good example of simple harmonic motion. Remember, simple harmonic motion, actually, since we're starting, is oscillatory motion. Okay? And I get a complete cycle. It goes back and forth.
We don't have a visual.
You don't have a visual? You don't have the teacher camera?
No, we're flat screen.
Okay, that's interesting. Let's see, we'll do this. All right. You got me now?
No, ma'am.
Okay. Let's see.
There we go.
Is it talking now? There we go. All right. The new system. Okay. I'm probably going to need a little help as we go. So simple harmonic motion, simple pendulum. I get a complete cycle. It has a period. It has a frequency. And it goes back and forth, right? That's one example of simple harmonic motion. The other common example of simple harmonic motion, we can do it two ways. I'm going to do the vertical way first, is our spring. And in our spring, we get the bouncing up and down. So I don't even want to see the horizontal one, because the horizontal one is another common example of simple harmonic motion. So I don't want to see 19 common examples. All right? I want you to come up with some better examples of simple harmonic motion, because they are everywhere. Simple harmonic motion is everywhere. Oscillatory motion is everywhere. So that assignment will be due Friday before Labor Day weekend. So it'll be due a week from Friday. So it's one of those lovely projects that you're going to be out there looking for while I am at the San Diego meeting. Okay?
Did you say this Friday?
No, a week from Friday.
Okay, a week from Friday, sorry.
Yeah, a week from Friday, the Friday before Labor Day weekend. Okay. All right, let's see if I can go to the document camera.
And we need an example, a video, and the equation.
Example, the video, and the equation. And we're going to start doing the equation right now. Maybe. Okay, are you seeing the document camera over there?
No.
Okay, we got it there. All right, got that. Now I'm going to do document camera. Okay. Just thinking. All right, you still no?
I want document. We had your computer for a second.
Yeah, I had the computer, and it's not coming up with the document camera. Let's see. That's on. That's showing up there. Teaching site. Oh, it's noon time, or 1 o'clock. Okay, that's interesting. Everything it's doing, but it's not showing up on my confidence monitor.
So, are there gonna be days where you're gonna be in, Enid,
Fridays.
Fridays? Okay.
Yep. Fridays I will be in Enid.
I just missed that.
Okay, let's see. Because if I go to desktop computer, it's showing the desktop now, right? Now if I go to the document camera, I'm getting nada. Try this. That was interesting. Okay, now that's interesting. Ah, you should see the document camera now. You got it?
Yeah.
All right, cool. Okay, my schedule, just so you guys know. Monday mornings, iffy. Okay, Monday mornings will be iffy because you guys are my first class, 12:30 on Mondays. I have a 5:30 evening class, so that tells you why Monday mornings will be iffy. So I have office hours during the afternoon. Our new ITV system is called Zoom, which means, especially for you guys at the far site, and especially for you guys on Friday, if you have a question, I can actually Zoom to your laptops. So you can actually, if you guys are out on a baseball game and you say, I can't have trouble doing this problem, holler at me and I can set up a Zoom face-to-face just like Skype or FaceTime or whatever you guys want to call it. And it allows me to write on my computer to do it, so we can do screen whiteboards. And we tested it over the summer with my dynamics class, worked like a charm. Worked really, really well. So even if I'm here or there, if you got a question, you can email me and we can set up a time and go for it. But I have Monday afternoon office hours. My Tuesday schedule is very interesting. I'm here at 7:30 in the morning for Intro to Engineering. Then I don't have anything until my 4 o'clock Concepts of Physics class. So I have designated office hours Tuesday morning, but because that's also Tuesday afternoons or faculty meeting times, I may or may not be around. And I have a 7 p.m. General chemistry class on Tuesdays and Thursdays. Wednesday, if I'm here after 2:30, it'll be a miracle. But I have an 8 a.m. general physics class. You guys are my 12:30, and then I'm out of here by about 2:30. Thursdays, totally going to be iffy if I'm on campus. Probably will be, but I have my 4 o'clock class. But that's the day I'm trying to get some stuff done. And then Fridays, I'll be in Enid. So that kind of gives you where my office, and my office hours are posted on the door. They are posted in the syllabus, so they're posted several different places. But, so I am around, and we got stuff going there. Okay, so back to where we were. We're going to start with fun stuff. Not a problem. So it's all right. We can go from there. So simple harmonic motion. I'm going to have to scroll out. Also called oscillatory. If I spelled it right, I'm not 100% sure. Oscillatory motion is dealing with, like our lovely little spring, that we're going up and down or back and forth. Pendulum does the same thing. We're going up and down, back and forth, okay? So we have an oscillation. Up and down, or back and forth. Now, we all know that the time that it goes to go from here to back is one complete cycle. And that's going to give us T for period. Right? The units of period are in seconds. And somewhere along the line, we've learned that the period is 1 over the frequency. Remember, frequency is numbers of cycles per second. So period and frequency are related, but they're inversely related. And the frequency, if it's in cycles per second, it's going to be in 1 over seconds, which has our lovely units of hertz. We have lots of things that have oscillatory motion. So let's take my handy dandy little thingy. Okay? And we know that my spring is going to give me a restoring force, right? Good old spring is going to give me a restoring force. And we recall, because even though it's been a while, we know that my force, and there we get our minus x, or minus kx. This is good old Hooke's law. And the negative comes from the fact that it's a restoring force and it's pulling it back. Okay, the spring is wanting to go back to its original shape, and it's going to give me that restoring force. So that's why the negative comes into play. And most of the time, we just intuitively knew where the negative was, right? If I'm doing it this way, I'm stretching it back and forth, going up and down that way. But most of the time, we just played with the fact that we dealt with the magnitude of that force was going to equal that. So dusting the cobwebs off, right? Just dusting the cobwebs off. If I have a spring, we could calculate this lovely spring constant. And that spring constant is related to the makeup of the spring. How many coils did that spring have? How thick that spring was? Each spring is going to have a physical constant associated with it, and that's related to the material. So when you guys get to strength of materials, I can have a metal bar. And my metal bar will also have a spring constant associated with it. Because I know if I apply and I look at the length as the force is being applied, so this is my change in length as a force is being applied. If I have a spring that goes up linearly, if I have a spring, it goes up linearly, but we also know if I'm doing this, I have a clamp on this particular bar, I have a clamp on this particular bar, and I start pulling it apart. Initially, it's going to go back to its original shape, but eventually it's going to do something like this, right? It's going to start pulling like a piece of taffy. And ultimately, it's going to break. And what you'll see is you'll see an element, and you'll see a deformation, and then you'll ultimately see a break. And that relates back to the strength of material, but there's going to be a region here that's going to obey Hooke's law. And we have other springs. This of course is our classic spring, right? When we think of a spring, we think of these right here. Okay guys, can you give me other examples of springs?
Leaf spring.
Leaf springs. Anybody been underneath their pickup truck? You got a spring that looks like that. A lot of times they're a folded leaf spring that kind of look like that. Leaf spring on a buggy looked an awful lot like that. You had your buggy attached to it, so these two springs would, or these two pieces of metal would bounce up and down. Another example of a spring. Anybody wind up a watch? It's a spiral. Got a spring that looks like that. Can I see a ruler in here? Somebody got a ruler? No ruler? No ruler?
Now, hold on.
In your door, in your bag.
Would a paper clip kind of be like a spring too, because when you take it out, it goes back too much?
Well, it depends on how you use it, because I've used paper clips as springs. I mean, it depends on how you use it. Typically, we don't think of paper clip that big. All right, that's gonna work. That's actually, that one's gonna show what I need to show really well. No, Springboard,
So like a diving board.
diving board, springboard. Now, this one is a perfect example of dampening motion, okay? Because if I use my other little spring, right, where did my spring go? If I use my other little spring, we've used these before, right? They'll sit there and they'll bounce for a long time, right? They're gonna bounce for a long time. We all know that over time, that gap between how far it separates out is gonna change. The thing about a springboard is that dampening happens really fast. And we also see that difference, that deflection. Initially, it's very wide, but it quickly dies off. And that's called a dampening effect. But that's another type of spring, okay? That's another spring. Come on, others. What about your leg? Toes?
Hydraulic? No?
Hydraulics are a little tougher. But you can get a hydraulic spring, and you can get a dampening effect on those. Muscle tendons are really springy. I mean, but it gets back to that's all based on our materials, right? That's all going to be based on our materials. It's all going to come back, and our K that we end up with, this lovely K, is going to be related to the material. And when we come back on Wednesday and I actually show you a problem, we're going to use some interesting things to get to that K piece. So, but that comes back, how that spring constant comes into play, so a couple things that we have to kind of remember. It's good old Hooke's law, because we're going to be using it. Hooke's law is going to be F is my restoring force minus KX, right? That's Hooke's law. We also know the potential energy of a spring is going to be 1/2 KX squared. Relating back to what my material is. We're going to see that a couple of times. The thing about my simple harmonic motion is that oscillatory motion gives me a function, a mathematical function that has oscillatory motion associated with it. 1/2 KX squared is potential energy of the spring.
That'd be like sine and cosine.
Sine and cosine. Because my sine and cosine, depending on what I've drawn, right? It's going to give you a function that looks like that. And if I'm doing just sine and cosine, we know what the top is and we know what the bottom is, right? Top and bottom, for sine and cosine, the top's gonna be 1, the bottom's gonna be minus 1. The sine and cosine go from 1 to -1. Now, the way I've got this drawn, because I don't have anything on that scale, which function is it? Why?
Because it starts at 0 and ends at 0.
I don't know. Because I don't have a time coefficient with it. I didn't give you anything on that cycle there. Yeah, I didn't give you anything to tell you which way it is. Because cosine can look just like that, depending on where I started.
For some reason I thought cosine always started at the number.
Oh, it does. But if I do this, I do cosine xt, and this is time. And I haven't given you anything there. You don't necessarily know. Right? Because cosine, you can do it either way, omega t plus 90 degrees, right? It's equal sine omega t. They're the same function. It's just a matter where you start. And that becomes important. Becomes important a couple different places. Becomes important, number one, for you guys, which math book, which physics book you pick up. And we'll talk about that on Wednesday. Because I can use both, okay? I can use either one. Your lab is going to be different than your book. Okay? Your lab will be different than your book because both of these are going to describe the same behavior. And when we get to electricity, it becomes real important when we start looking at phasor diagrams. So we will see it again. But for simple harmonic motion, it doesn't matter. I'm going to show you the convention that we use in the book, but when you guys do the lab, we're going to use the other convention. This makes it fun. Because I've got 2 minutes, and I know I'm going to lose my Zoom room. We're going to stop there. We're going to dive into this more on Wednesday. We will meet on Wednesday. For you guys, you don't have lab on Thursday, but we will do it right after class on Friday. Yes, sir. There's one at the door, or you have a question? Okay. Yep, swing set's gonna be a swing set is way too simple. Yeah.